Okay, here we go. Pressure. Pressure is another ratio. Pressure is a ratio of force divided by area. So pressure is how much push. So force is that amount of push. Oops, not pash, push. Push divided by area. So push divided by, how about instead of area I write surface. So pressure is the amount of push there is divided by the amount of surface you have. So it's kind of like speed. Speed is distance over time, or it's kind of like density. Density is mass over volume. These things are also ratios. So what do we measure these in? Forces we measure in newtons, and area we measure in typically square meters. If you measure in newtons per square meter, we call it the Pascal, named after a famous dead guy, abbreviated PA. So my point of this video in the next couple minutes is to help you understand this ratio of force divided by area. So let's talk about a few things. Let's talk about high heels. Okay, so if you're wearing high heels, and some of you probably do, but maybe not all of you, but look at how little area actually touches the floor in high heels. And imagine if you balanced your weight just on the heel, how little that area is. So if you have this equation, P equals F over A, and let's just say that you make the A a really tiny number, a little tiny A, then that means the bottom number gets smaller. That means the pressure gets bigger. So if you wanted to apply a lot of pressure with your heels, you would stand on the heel. Okay. So other examples. How about this? If you want to not fall through the ice, what do? You spread out over the ice. You lay your arms and legs out as flat as you can. So by doing that, what you're doing is this. You're making the area very big. So if you make the bottom of the fraction very big, that means that you make the pressure very small. Okay, so pressure is force divided by area. Other examples related to this, how about these things? They sell these little tools that you can keep in your glove box in case you have an emergency, you need to break your window. It's this tiny, tiny little pointed tool that has a very small area, so it's kind of like the high heel. Other examples, let's see, I Googled, and this is the best I could find. I was kind of surprised this is the best I could find, but you can survive being run over by a tire if the area is big enough. Because if the area is big enough, then what happens is the pressure is very, very small. So these people are lined up and they're being run over by some kind of vehicle at the South Pole. I really did think I'd be able to find a video of someone being run over by big fat tires a lot easier, but I couldn't find anything. If you find something, let me know. How about pressure at altitude? What if you go up high in the sky and you want to know what the pressure is? So I don't know if you've noticed this before, but if you buy like cake mixes or pasta things, they'll tell you that if you go up high into the sky, you need to cook that stuff longer. So the higher up you go, the higher your altitude is, water boils at lower and lower temperatures. Check this out. At sea level, water boils at 100, but if you go up in the mountains, 14,000 feet, water boils at 86. So water boils, but it's nowhere near as hot. So if you cook stuff up high, then you have a lot less pressure. So what is that talking about? Is that talking about force or area? That's actually talking about force, because let's say this is the Earth and here's the atmosphere. This is a grossly exaggerated picture, but down here at the surface of the Earth, there's more air pushing down on us. But if you were up on a mountain, like this hugely exaggerated mountain here, if you were up on top of this mountain, you have a lot less air pushing down on you, so there's less force per unit of area, so your pressure goes down. One more example before I close out here. What if you do this? What if you dive down deep in the ocean? That's another way to change force. The deeper you go, the more water you're under. So that's like saying your force is a huge number and the area of your body just stays the same. So your area stays the same. So if you make the top number bigger, then your pressure becomes enormous. Okay, so that's the idea of pressure as a ratio.